Okay, so we're also going to do an LCM practice. And again, just like GCF, if you watch that one, the idea of this is I want you to pause the video and try it on your own, and then push play and watch me go through it and see if you got it right, and if not, figure out where you are going wrong with your process. So this is LCM. Remember, LCM is least common multiple, and multiples, remember, are just like skip counting. Skip counting. Okay, and we're going to kind of work backwards so that we remember the difference between the two. The first question was the production line in a fast food restaurant puts ketchup on every third burger and mustard on every fourth. Which is the first burger that will have ketchup and mustard? Okay, so we have our ketchup is going to be on every third, and our mustard is going to be on every fourth burger. Okay, the key word for LCM in here, there really isn't one, but there's a situation you'll see over and over again is when they're looking at two things or three things happening, and then you're looking for the first time that they have something in common. So like our burgers, they're looking for the first one that has both. So we're looking at first, this is going to be LCM, and just like GCF, we're going to work backwards. Remember that M means multiples. Multiples get bigger. So we're going to start with our burgers that have ketchup. It said they're on every third burger. Well, it wouldn't make sense to get smaller because the second burger, the first burger, doesn't have anything on it according to our story. It starts with the third, so our numbers have to get bigger. So the third burger has ketchup. Well, then that means that the sixth burger is going to have ketchup. The ninth burger is going to have ketchup because we're starting to skip count by threes. 3, 6, 9, 12, 15, and so forth. Okay, I'm going to stop and I'm going to look at mustard. Mustard, it says every fourth burger gets mustard. That means that every eighth burger is going to have mustard, and we're counting by fours. But what I'm looking for is between the two lists when our number ends up the same. Right now, I have 3 with ketchup, 4 with mustard. Those don't match. 6 ketchup, 8 mustard, those don't match. So I'm going to keep going. 4, 8, 9, 10, 11, 12. Okay, now I'm going to stop because what I notice is I have the number 12 burger has ketchup on it. Well, now I'm seeing that same number on the second listing for mustard, which means that the 12th burger got ketchup put on it, but it also has mustard put on it, and that's what we were looking for in our problem. So LCM, M being multiples getting bigger, skip counting. C is our common. Where are they the same? So they're the same at 12. If I kept going, they would also be the same at 24 and then 36. But remember that I'm looking for LCM, meaning least, which just means the first time that they have a number in common. So for this specific one, we have a 12, which means that the 12th burger has both ketchup and mustard. Okay, so let's try another one, because LCM is not always going to be the first something that has in common. Number 2 says Lucy is surveying every 5th person who comes out of the grocery store. Mr. Watkins is the 72nd person out of the grocery store. Will he be surveyed? Okay, with this one we talked about in class, we really don't even need any work here. But yes or no is not going to work. We need to tell why. Okay, so let's look at the number 72. If they are going to survey every 5th person, well, that means you're skip counting by 5s. That's 5, 10, 15, and so forth. Well, think about divisibility rules that we had talked about. If my number ends in a 2, Is it gonna be divisible by 5? Are we ever gonna land on a 2 when our pattern looks like 5, 10, 15, or pattern is 5, 0, 5? No. So my answer is no, and it's because 72 is not divisible by 5. So yes, we threw divisibility in there. How's it LCM? Well, I could have done my multiples of 5, 5, 10, 15, 20. I would have got all the way up to 70, and then it would have jumped to 75. So it is LCM, but many of you immediately saw the divisibility rule there, and so we just use that. Either way, you get the same answer, but we like to try to do things smarter, not longer. So if you could immediately see the divisibility there, we don't need to write out skip counting by 5s until we get all the way up into the 70s. Okay, so let's look at more of a routine LCM. For number 3, pause the video, try it on your own, and then push play and see how you did. Okay, so for number 3, there are 5 party plates in a package. There are 12 party napkins in a package. What is the least number of plates and napkins you can buy to get 1 napkin for each plate? How many packages of each will you buy? Okay, so we have 5 party plates in a package. There are 12 party napkins in a package. What is the least number? Okay, this is the great one because this one, there is no doubt, our key word is least. How do we know that matches? Well, because LCM also starts with least. So we know we're using LCM, but we're going to work backwards. Remember, LCM, M stands for multiples. Multiples get bigger. Okay, so let's start with we know we've got plates. They are 5 per package. So I know that if I go and buy 1 package, I'm going to have 5 plates. If I buy another package, I'm going to have 10 plates. If I buy 3 packages, I'm going to have 15 plates. 4 packages, I'm going to have 20 plates, and so forth. For my napkins, those don't come in packages of 5. They come in packages of 12, but I need the same number of plates as napkins. So I'm trying to figure out how many I need to buy for that to happen. Well, if I buy 1 package of them, of napkins, I'll have 12 napkins. That doesn't match my plates, so I have to keep going. If I buy 2 packages of plates, I'm going to have 24 napkins. That doesn't match, I'm already over my plates. Okay, I'm going to do some more here. If I buy 3 packages, I'll have 36. Again, I'm thinking about the divisibility rule. My plates are in 5, so I'm thinking 5 is not going to go into 36. So I'm going to keep going. 36, then I would have 48 would be 4 packages. Still, my 5 is, I'm not going to run into 48 with skip counting by 5s. So then I'd buy another package of napkins, and 5 packages gives me 60. Okay, well, 60 is a nice round number. 0 is at the end. Divisibility rules say that 5, skip counting by 5, I should end up on a 60. So I'm going to continue with my plates. We were at 4 packages means 20 plates. So then 5 packages would mean 25. 6 packages would mean 30. 7 packages would mean 35. 8 packages would mean 40. 9 packages would mean 45. 10 packages would mean 50. 11 packages would mean 55. 12 packages would be 60. And finally, I see a common number. I have 60 plates, 60 napkins. But be careful because the question asks how many packages. If I answered 60, what I would be answering is I'm going to get 60 packages of each. I'm going to get 60 packages of plates and 60 packages of napkins. Well, now all you have is a whole lot of plates and a whole lot more napkins. You still don't have even of each, and that's what the whole point of the question was. So make sure you're looking. This is why I label the packages with it, because if it's asking for packages, I need to answer packages. For my plates, I only need 12 packages because that equals 60. But for my napkins, I only need 5 packages because that gives me a total of 60. So my answer, 12 packages of plates, 5 packages of napkins. Be really careful that you're looking at what they're asking you for. Okay, we'll do one more. Let's see, these are all packages, so we'll just do the next one. Mark, pause the video, try it on your own, and then come back and check it with me. All right, so you should try this one on your own. Let's see how you did. Mark is building a birdhouse. He needs an equal number of blue tiles and red tiles for the roof. So we're looking at equal again. The problem is blue tiles come in packages of 12 and red tiles come in packages of 18. Of course, they don't come in packages with the same amount. So he needs to buy the fewest number of tiles and have none left over. How many packages? Okay, so let's start with, we've got blue tiles. Blue tiles come in packages of 12. So if I buy 1 pack, I'm going to have 12 blue tiles. If I buy a second pack, I'm going to have 24 tiles. If I buy a third pack, I'm going to have 36. If I buy a fourth pack, I will have 48. Okay, I'm going to stop there just so I can see where my numbers look like for the red. So red tiles come in packages of 18. So if I buy 1 package, I will have 18. And then if I do another package, I would have 36. So I'm going to stop because I see that I have a common number. I notice 36 and 36 are the same. And now I'm looking for, and they're the least because they're the first number that I have in common. It's the first time I'm seeing a common number. But again, go back. They asked for packages. So my answer can't be 36 because then I'm saying I'm buying 36 packages of each. My answer needs to be that for my blue tiles, I bought 3 packages, and for my red tiles, I'm buying 2 packages. So just be careful that you're going back and answering the question.
Videos out.